Today, we are playing around with linked lists. We are playing around with odd-heavy arrays. We are converting ISBN-10 strings into ISBN-13 strings. And then, we are playing a game of greed. Hello world, and this is versus Codewars. And I hope everyone is having a wonderful and safe day today. We begin today's warm-up segment with a function that calls for us to return a new array with processing every number of the input array as follows. If the number has an integer square root, we take that square root. Otherwise, we take that number squared. Let's go ahead and get started with this one right here. We have const square or square root. And we'll have our array of numbers right here. And what we will do with that array of numbers, we're going to run that through the map method here. And in our predicate function, we'll have our number right here. And what we will do, we're going to go ahead and take the square root of that number right now with the math.sqrt function here. We're going to pass in that number here. Now, we're going to take that square root and divide it by 1 and get its remainder. And if that remainder is 0, then this number has an integer square root. And we'll go ahead and return that square root. And that square root will be pushed into the array returned by the map method here. Otherwise, if this number does not have an integer square root, the Kata solution calls for us to return that number squared. So number times number, or number to the power of 2, using the arithmetic exponent operator here to raise this number to the power of 2. Alright, let's go ahead and punch this into Codewars to see what this looks like. I'm going to run the tests. And we are good on that. For our next warm-up, Kata. For our next warm-up, Kata, we are to complete a function which converts a binary number, given as a string, into a decimal. Let's go ahead and get started with this one. Const bin to dec. And we are going to have our binary string right here. Now, we're going to go ahead and keep track of a result integer right here. We're going to set that initially to 0 here. And we're going to return that down here. Now, what I think we will go ahead and do, we are going to go ahead and read this binary string from right to left. And then for each one that we encounter in our binary string, we need to add to our result the value of 2 to the power of that particular one's position in the binary string going right to left. So 1 would be the very start. 2 would be the next character here. And so on and so forth. What we'll go ahead and do, we're going to do for let I equals, we're going to do a two-tiered for loop here. So we're going to do for let I equals, we're going to start I at the length of our binary string -1. And then we're going to have a second initializer right here. Exponent, we're going to set that equal to 1. Now, we're going to do I, we'll continue until I, as long as I is greater than or equal to 0, and then minus I, and plus exponent right here. Alright, now what we're going to do inside this for loop here, I'm going to zoom out a little bit here. What we're going to go ahead and do, if result at index I is equal to the character 1, then what we are going to go ahead and do, we're going to do result plus equals 2 to the power of exponent right here. And that should be all there is to it right here. I'm going to zoom back in here. I'm going to go down to one of these tests here. And what we're going to go ahead and do is console.log. We're going to test our function out here. Bin to dec, and we're going to pass in a string 100101. Now, 10010001 is the binary representation of the number 73. So I expect that to be the return value here. So what we'll go ahead and do, we're going to do node warmup bin to deck, and we get 0. And we were not expecting to see that because we were attempting to index our result here. We need to index our binary string here. Alright, let's try that again here, and we get 146, and we do not want that here. Alright, let's go ahead and console.log our binary index I here. And let's try to get down to the bottom of this here. And we'll log our exponent as well. To the power of 1. Let's console.log our result here as well. Let's move this down here, and then we'll log our result here as well. Unless maybe we needed to start our exponent as 0. Yep, that was the problem. When evaluating a binary string, we actually had to start our exponent as 0 because the binary 1 alone is the number 1. 2 to the power of 0 is 1. Alright, let's go ahead and punch this into Codewars to see what this looks like here. Let's run our tests. And we are good on that. For our next warm-up kata, we are writing a generic function chainer here. The goal of this kata is to write a generic function chainer that takes a starting value and an array of functions to execute on that value. The input for each function is the output of the previous function, except for the first function, which takes that starting value as its input. The goal of this kata is to return the final value after the execution is complete. I'm going to go ahead and copy these two functions over to our local solution here. And let's go ahead and get started with this one. Const chain, and we'll have our initial input and our functions right here. And I think we can actually do this in one line here by taking our array of functions and running it through the reduce method here. We'll have our function here, and what we need our result and our function right here, and our predicate function here. We'll go ahead and call that function upon our result as of right now, and we'll set that initial accumulator to our initial input here. Alright, let's go ahead and test this out here. We'll do console.log chain, we'll pass in 2, and then we'll pass in our add and mult functions up above. Let's go ahead and test this out here. Clear the terminal, node warmup chain me, and we get the number 90 for our return, and that is what we want to see here. Alright, let's go ahead and punch this into Codewars to see how this looks like here. We're going to run our tests. We're going to hit attempt, and we are good on that. For our next warm-up kata, we are given a number, and the goal is to define its score by calculating the value of 0, pipe 1, pipe 2, pipe 3, pipe all the way up to n, where the pipe symbol is the bitwise OR operator here. Alright, let's go ahead and get started with this one here. We're going to do const score. We're going to have our number here. We're going to have our result here. And what we're going to go ahead and do think this is what we do here. For let I equals 0, I is less than number, or rather less than or equal to number, plus I, we do result, or equals I here. Alright, let's see what that looks like here. Console.log score 1,000,000. We're going to do node warmup or score. And we get the value 1,048,575. And that is what we want to see here. Now, the OR bitwise operator takes the two bits and compares them, and it evaluates to true if one of those two bits are set to 1. It also evaluates to true if both bits are set to 1, but evaluates to false if neither of the bits are set to 1. Let's go ahead and punch this into Codewars to see what this looks like here. Oh, I do not like the look of this here. Looks like we're dealing with big numbers here.
Let's have a look at this. Let's try that again here.
Alright, let's go ahead and grab that here. Let me copy that, paste that in here. Alright, obviously our code is going to have to be much faster than this.
Let's try that just one more time here.
Alright, I'm going to have to be right back. Give me a few moments. Alright, I found where I was going wrong here. What I was initially doing, I was stepping by 1 for each iteration of our for loop here. Unfortunately, that is not performant enough for this Kata solution, and that was leading to timeouts here. I had noticed a little bit of a pattern and where I was going wrong here, and I realized what I could do actually was omit this step right here in the body of our for loop, and then in this part of our for loop, we instead set I to the result of our OR operation in this iteration here, plus 1 here. Now, running this through node, we get the same result right here, 1,048,575. Let me go ahead actually and pull a value from one of our failed tests here. Let's grab this very large number here, for instance. I think that is 1,019,102,616. Let's go ahead and copy that and paste that right here. Let's run this through node. Yeah, much more performant here. Alright, let's go ahead and try this through Codewars to see what this looks like here. I'm going to hit test. I'm going to hit attempt. And we are good, finally. Now, finally, we are following up with our binary score with a binary XOR. We're doing just like what we did with the previous warm-up kata. This time, however, we are using the XOR operator, or the exclusive OR operator. The exclusive OR bitwise operator compares 2 bits, and it evaluates to true if one and only one of the bits are set to 1. It will evaluate to false if both bits are set to either 0 or if both bits are set to 1. Let's go ahead and give this one a try here. Alright, we'll do const sXORe, and we'll have our number right here. We're going to keep track of a result just like we did previously. I'm going to return that result here. I'll go ahead and console.log this down here, sXORe. We're passing 1 million here. Now, let's go ahead and do this for loop again here. Let I equals 0, I is less than equal to number plus plus I. Let's see what happens if we did this again here. Now, in JavaScript, the XOR operator is the caret. Shift 6 on your keyboard here. So caret equals I here. We're going to go ahead and console.log that I and our result here. And we are going, let's go ahead and run this through Node to see what this looks like here. Node, warm up, XOR score. Actually, let's go ahead and get rid of that console.log here. And try that again here. And we get 1 million here. Let's try the number 50. I expect to see the number 51 here, and we do. Alright, let's go ahead and punch this into Codewars to see what this looks like here. Now, I think we all know what's probably going to happen if we submit this solution here. Let's go ahead and run the tests. Let's go ahead and hit attempt. And wait the 12 seconds to see that our submission has timed out. Alright. We'll go ahead, I think we'll go ahead and do just what we did in our OR score here. Let's go ahead and get rid of the step. And then we are going to go ahead and set I equal to results, I think plus 1 here. Run that through Node, and uh-oh. I think we got a new problem here. 63 is definitely not equal to 51. Let's go ahead and actually set that to our result here. Alright. Now where are we going wrong? Alright, let's go ahead and console.log our numbers here. And wait out the 12 seconds here. Now, let's go ahead and console.log our I and our result here. And let's see where we're going wrong here. And that's an infinite loop. Gonna add our step back here.
Zero, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, huh. You're seeing a bit of a pattern here as well.
I will be right back once again. Give me a few moments. Alright, I'm back and I think I know what the pattern is here. So I'm going to go ahead and get rid of all of this here. What I'm going to go ahead and do is, I think first we're going to check to see if our number is divisible by 4. If our number is divisible by 4, then we'll just go ahead and return our number. Else if our number is divisible by 2, we'll go ahead and return our number plus 1. And then if our number is odd, now this is where it gets interesting here.
Zero 1 3 0 5 1 7 0 9 1.
Okay. Else if number plus 1 is divisible by 4, we return 0. "12 is divisible by 4. No, that ain't it. Alright, I'll be right back again. Give me a moment. Yeah, I think I had my thinking right here. Looking at the pattern here. If our number plus 1 is divisible by 4, then we return 0. And then if our number plus 1 is divisible by 2, yeah, get rid of that. Then we'll go ahead and return 1. I think that's what's going on here. Yep. Let's go ahead and try that big number again here. Get that 0 here. Let's try that 1 million again. And let's try that 50. Alright, I hope we're good now to punch this into Codewars to see what this looks like. This one does not involve any for loops. And we are good. Boy, those last couple katas were a couple brain busters. I did not expect those to be, but I'm glad I solved them. That concludes today's warm-up segment. I will see you in the next kata. Alright, during the past episodes of Versus Codewars, you've become familiar with me using the Array.prototype.reduce method. This method takes two arguments, a predicate function that works on an accumulator and an initial accumulator. In this kind of solution, we are implementing the reduce method with a catch. Instead of an array, we are going to be working on a linked list. In this implementation of reduce, we're going to have three arguments: the head node of a linked list, the predicate function, which takes our accumulated value and current element data, and an initial accumulator value. This method should return the result of applying the given function on every element in node in that linked list with the accumulating result, starting with the initial value. Alright, let's go ahead and get started with this one. First, we're going to go ahead and copy our node over to our local solution here. As you can see, this node class here takes two arguments, the data and next. I'm actually going to go ahead and re-implement this as a class. Give me just one moment here. Alright, let's go ahead and get started with this one here. I'm going to have constant reduce. We're going to have our head node. Our predicate function here, and our initial value here. And what we're going to go ahead and do is if our head node is not null, if our head node is set to null, we're going to go ahead and return our... Actually, what we're going to go ahead and do, let's do let current node equals head node. And then while we're going to have a result here, we're going to set that equal to our initial value here. And then we're going to do while head, or rather current node is not null. And what we're going to go ahead and do, we are going to go ahead and set our result, the current result, to the return value of our predicate function here. And we are going to pass into this predicate function our accumulated value, which is going to be a result. And then we are going to pass in the data inside of our current node. So current node dot data. And then after that, we are going to go ahead and set our current node equal to current node dot next. All right, let's go ahead and test this one out here. Let's go ahead and go down into our tests here. Let's go ahead and grab... Let's go ahead and grab this one right here. Let's go ahead and copy that. Do console.log. I think that's right here. Let's go ahead and feed this in a node here. Fun with list reduce. And we get back undefined because we did not return our result here. And we get the number 6 for our result, and that is what we want to see. Alright, let's go ahead and try punching this into Codewars to see what this looks like here. Run the tests. And we are good. Not really much to say about this one, so in lieu of a reflection, I'd like to show you a little bit of a trick on how you can flatten a linked list into a regular array, so you can run that array through the regular array objects reduce method. Let's go ahead and give this one a try here. We're going to do const flatten, and we're going to give it to the head node of our linked list here. And what we're going to go ahead and do, we're going to go ahead and keep track of a result array here, or const result equals an empty array. We're going to return our result right here. Now, what we're going to go ahead and do, let current node, and we're going to set that equal to our head node for now. So, while current node is not equal to null, we're going to go ahead and result.push our current node.data here. And then we'll go ahead and set our current node equal to current node.next here. And in so doing, we will have flattened our linked list into an array here. All right, let's go ahead and give this one a try here. I'm going to replace our reduce call here to flatten. And then we're going to go ahead and run that array, flattened array, through the reduce method here. And we're going to pass in this predicate function right here. And this should work as well, I do believe. Wait, yep. Let's go ahead and actually, whoop. Let's go ahead and actually, get rid of this right here. We're going to do flatten. new node, 1 new node, 2 new node, 3 null. Then we're going to take all of that and run that through the reduce method. And we're going to have our val plus a val with 0 as our initial accumulator. And let's go ahead and test this out here. And new node is not defined. And we get our 6 once again. So what we just did was we took our linked list, we flattened it into a regular array, so we can use that resulting array with the regular array objects reduce method here. Alright, I will see you now in the next kata. An array is said to be odd heavy if it contains at least one odd element, and every element whose value is odd is greater than every even valued element in the array. The goal of this kata is to write a function that accepts an array of integers and returns true if the array is odd heavy. Let's go ahead and give this one a try here. Const is odd heavy, and we'll have our array of numbers here. Alright, let's go ahead and give this one a try here. First, let's go ahead and split out all of the odd numbered and even numbered elements of our array. So const odd numbers equals numbers dot filter number modulo 2 is not equal to 0, and then const even numbers dot filter number modulo 2 is equal to 0. Alright, so go ahead and console.log those. Odd numbers, even numbers. Alright, let's go ahead and grab this array right here. I'm going to get copy. Console.log is odd heavy. I'm going to pass in that array here. Let's go ahead and test this one out here. Odd heavy. And as you can see, we have two arrays. One of our filtered odd numbers and the other of our filtered even numbers here. Alright, let's go ahead and continue on here. Alright, we're going to go ahead and take our... We're going to iterate over the odd numbers of our array here. For const odd number of odd numbers. And then we're going to go ahead and iterate over our array of even numbers. For const even number of even numbers. Now, if this even number is equal, I think, to greater than or equal to, I believe, of our odd number. Well, that would be impossible because an even number can't be equal to an odd number. If our even number, anyway, is greater than our odd number, we'll go ahead and return false because now we know this array is not odd heavy. Now, if we make it to the end of this outer for loop without returning false here, then we should know that this is an odd heavy array. So we'll go ahead and return true down here. Alright, let's go ahead and test this out here, and we do get true for this initial array here. Let's go ahead and grab another one here. Let's grab this array right here, which is not odd heavy. Let's paste this in here. And we get false for this second array here. Alright, let's go ahead and punch this into Codewars to see what this looks like here. Let's go ahead and run our tests. Let's go ahead and hit attempt. And looks like we got a few problems here. What is going on here? Alright, let's go ahead and console.log our odd numbers and even numbers. and hit attempt again. And I think the issue at hand is our odd numbers array is empty. So what we can go ahead and do, obviously an array cannot be odd heavy if it doesn't contain any odd numbers. So if odd numbers.length is equal to 0, we'll return false here. Let's go ahead and copy this if block into our Kata solution here. And let's hit attempt again. And we are good. Here is the better code solution of the day. Pay mind to the code snippet you see to your left here. Here we keep track of the minimum odd and the maximum even integers, set initially to the maximum safe and the minimum safe integers respectively. Here in this Kata solution, a single for loop is utilized rather than the two for loops that we use in our Kata solution. In this one, we iterate through each of the numbers of the given array. And if that number is an even number, we check to see if that even number is greater than the currently recorded maximum even number here. And if it is, we set a new maximum even number. If the number is on here, we check to see if this odd number is less than the currently recorded minimum odd number here. Finally, at the end, we return true if the minimum odd number is not equal to the maximum safe integer, and that odd number is greater than the currently recorded maximum even number here. In so doing, this solution is more performant, and it handles everything with just a single for loop. You may recall in a previous episode of Versus Codewars, we wrote a function to check to see if a string was a valid ISBN-10 book code. In this Kata solution, we are taking an ISBN-10 book code string and converting it into ISBN-13. For more than 30 years, ISBNs were 10 digits long, until the turn of 2007, when the ISBN system was switched to a 13-digit format. Now all ISBNs, International Standard Book Numbers, are 13-digit long. Actually, that is not a huge difference between them. You can convert a 10-digit ISBN to a 13-digit by adding the prefix number 978 to the beginning and then recalculating the last check digit using a fairly simple method. First, we take the ISBN. We remove the last character, which can be a number or a capital X. We add the 978 prefix and a hyphen to the start. We take the resulting 12 digits, and then alternatively multiply each digit from left to right by 1 or 3. And then we add up all 12 of the numbers that we get. We take that resulting sum, and we divide it by 10 and get its remainder. If that result is 0, then the check digit is 0. Otherwise, we subtract that result from 10, and that difference becomes the check digit. That check digit will be added to the end of our result string here. The goal of this kata is to perform this method and return the converted 13-digit ISBN in the appropriate format. Prefix number, hyphen, original ISBN except for the last character, hyphen, check digit. Alright, let's go ahead and get started with this one. I'm going to hit train. Const ISBN converter. We'll have our ISBN 10 string here. Now, what we need to do, I think we can safely assume that the ISBN 10 string will be valid here. So, what we'll go ahead and do first, we're going to go ahead and take that last character out. And I think we also need to take that hyphen out as well. Maybe not. Okay. What we'll go ahead and do here I think we'll go ahead and const last digit removed. We'll go ahead and set that equal to, I'm going to zoom out here, ISBN-10 dot slice. I think we slice from 0 to -1 here. I'm going to go ahead and console.log that and see what that looks like here. Go ahead and take this string here, do a console.log ISBN converter. Alright, I'm going to go ahead and run this through Node to see what this looks like. I'm going to zoom back in here. Node, ISBN-13. And we get that ISBN-10 string with that last character removed. And that is what we want to see here. Alright, next what we'll go ahead and do is, I'm actually going to go ahead and rename this results. And what I'm going to go ahead and do, I'm going to go ahead and append the 978 to the end of this here. And then I'm going to go ahead and do a placeholder right here. I'm going to turn this into a template string. Now, what we need to go ahead and do now, we need to take the 12 digits of this resulting string and then alternatively multiply each digit from left to right by 1 or 3. I think we start with 1 and go to 3 and then go to 1 and so on here. Alright, what we'll go ahead and do is we're going to go ahead and calculate the check digit here. So what we're going to go ahead and do, const added digits, and we're going to set that equal to, we're going to take our result string, split it into its individual characters, and run that through the reduce method here. We're going to have our sum and our digit here in our predicate function, and we also will need the index as well in this case. I'm going to zoom back out here. Write out this predicate function here. Now, we'll check to see if first and foremost if our character here is a number first. And I think we'll go ahead and do a... Now, we can safely assume, I think we can probably assume that our ISBN-10 strings are valid, as I asserted before. So, right off the bat, we can do if digit is equal to the dash character here. We'll just go ahead and return our sum here and just move on to the next iteration of the reduce method's predicate function. Next, what we'll go ahead and do is go ahead and return, actually, if our index is an even number, so if we were starting at 0 or if we were at index 2, what we'll go ahead and do, we'll go ahead and take our sum and add to it the digit multiplied by 1. Or rather, we could just go ahead and do the digit right here. Otherwise, if this is an odd numbered index here, we'll go ahead and take our sum, multiply that by the digit times 3. And with this reduce method here, we end up handling step 5 at the same time here by adding up all the 12 numbers that we get from this ISBN-10 modified ISBN-10 string. Now what we need to do, we need to calculate a check digit here. So we'll do let check digit equals added digits modulo 10. We're taking the sum of our added digits, dividing it by 10, and getting the remainder. And if that remainder is 0, we'll go ahead and, or rather, if that check digit is not 0, that remainder is not 0, excuse me, we will go ahead and do check digit equals 10 minus check digit. And the difference here will be our ISBN-13 check digit. Finally, we can go ahead and return our result string and then our check digit here. Alright, running this through Node, I can already see we've got a little problem here.
We'll subtract the result from 10. Alright, we've got a little bit of a problem here. Alright, let's see what's going on here. Alright, we can go ahead and console.log our added digits.
I see where we are going wrong here. We're concatenating strings here. Alright, we need to set up an initial accumulator here. We're going to set that to 0. And that does not seem to do it either. Let's go ahead, actually. I think I know where we're going wrong. We're not parsing the digit here, which is actually a string. And I think that is the correct ISBN-13 string that we have here now. Alright, let's go ahead and run some other tests here. How about... Oh, wait. We do need to account for... No, I don't think we do, actually. We'll go ahead and... How about me try this string here? 97800234645-6. Yeah, that's not right. How about another one of these strings here? Let's undo that. Oops. 9780141439151-8. Alright, that's right. How about this one right here? We're going to copy this over right here. Let's try this one here. 978-963-142-164-4. Yeah, that's not right. Okay, what's going on here? Yeah, some of our tests here are not checking out here. Let's go ahead and console.log that added digits again. Oh, wait a minute. Okay. I think I know where I'm going wrong here. Alright, what actually we need to do is filter out those dashes here. And then run that filtered array through the reduce method. Alright, now we're getting the right numbers here. Let's try that other one again here. And yep, I think we got it right now. Alright, think I'm ready to punch this into Codewars to see what this looks like here. And we are good. In hindsight, what I also could have done with that initial result string was to just append the 978 before it without that hyphen, and then run that string through the replace method using a regular expression to replace any instance of a hyphen in that ISBN-10 string with an empty string. In so doing, I could have been more easily able to run that string split into its individual characters through the reduce method without having to account for those dashes using the filter method or inside the reduce method's predicate function. Returning to the subject of linked lists, the goal of this kata is to write functions that calculate the length of a linked list and the number of occurrences of a certain piece of data in a linked list. Let's go ahead and give this one a try here. First, let's go ahead and implement this length function right here. And what we're going to go ahead and do, we're going to go ahead and keep track of a result here. Actually, first we're going to go ahead and check to see if our head is null here, in which case we return 0. Now, let's go ahead and keep track of a result here. And we are going to return that down here. And we're going to have a actually handle this edge case up here. And we're going to go ahead and keep track of the current node here. And while current is not null, we'll go ahead and do result ++ and we'll set current equal to current.next. And that should be our length function right here. Next, let's go ahead and implement the count function here. We have our head node here, and we have the piece of data that we want to look for and count the occurrences of in our linked list. Now, what we're going to go ahead and do here, I think what we'll go ahead and do is, again, we'll have our result here, and we'll have our current here, set that equal to the head, while current is not null. Alright, we need to go ahead and check to see if the data of this current node matches up with the data parameter that we pass in here. So if current.data is equal to data, we're going to go ahead and do our result ++ here. And then we'll go ahead and set our current equal to current.next to assign the next node of our linked list here. And then we'll go ahead and return our result down here. Now, what we'll go ahead and do, have a look at some of these tests here. Actually, we'll go ahead and try punching this into Codewars to see what this looks like here. I'm going to run these tests here. And these tests pass. And we are good. Greed is a dice game played with 5 6-sided dice. And your rolls will be scored as follows. You get 1,000 points for 3 1s. You get 600 points for a trio of 6s, 500 points for 3 5s, 400 points for a trio of 4s, 300 points for 3 3s, 200 points for 3 2s, 100 points for a single 1, and 50 points for a single 5. A single die can only be counted in each roll, once in each roll. For instance, a 5 can only count as part of a triplet worth 500 points, or as a single 5 worth 50 points, but not both in the same roll. The goal of this kata is to score a throw according to these rules. We will always be given an array with 5 6-sided dice values. Let's go ahead and get started with this one here. And we are given an array of dice rolls here. each die being represented by integers. All right, let's go ahead and get started with this one here. All right. First, what I think we'll go ahead and do is sort our die rows here. And what we'll go ahead and do, const sorted dice. We're going to set that equal to dice.slice.sort. I think we'll go ahead and sort these in ascending or rather descending order here. Now, this call to slice is necessary because in JavaScript, the sort method mutates the original array. Alright, now what we're going to go ahead and do is... yeah, what we'll go ahead and do is... while sorted dice length is equal to 0 is greater than 0, and we'll go ahead and keep track of a score here. Now let's go back to that score chart here. I think what we'll go ahead and do is if sorted dice at index 0 is equal to sorted dice at index 1 and sorted dice at index 0 is equal to sorted dice at index 2, then we know we have a triple score here. Let me go ahead and zoom out here just so you can see all that here. I don't think it was a very good idea to have this microphone in the way of my screen here. My apologies for that. But anyway, if this is the case here, then we know we have a triple score here. So what we'll go ahead and do is we're going to go ahead and check to see if check the value of our sorted dice, the sorted die at the first index here. Switch sorted dice at index 0. And then case 1, we'll go ahead and add 1,000 points to our score. Case 2, we'll add 200 points here. Case 3, we'll add 300 points. Case 4, we'll add 400 points. Case 5, we'll add 500 points. And then case 6, we'll add 600 points. And then, at the end of the switch statement here, we'll go ahead and pop these 3 die from the start of our dice array here. So we'll do sorted dice equal dot splice from 0 through, well, do splice 0, 3 here to get rid of those 3 die from the start of our dice array here. Now, otherwise, if we don't have a triple score here, what we'll go ahead and do is we'll do another switch statement here. Sorted dice at index 0. Case 1, we'll add 100 points. And case 5, we'll add 50 points. And then otherwise, we'll just go ahead and break here. Anything else is not worth any points in this case here. And then we'll go ahead and call sorted dice.splice 0, 1 here. And we will continue this until our sorted dice array is empty. Now, once we get to the end of this while loop, we'll go ahead and return our score here. Alright, let's go ahead and test this out here. We'll do console.log. Do an array. We'll do score. We'll pass in an array 5, 1, 3, 4, and 1. And I expect to see a score of 250 here. I'm going to zoom back in here. Node agreed. And we get to the score of 250 points. And we do want to see that. How about 1, 1, 1, 3, and 1? And we get 100 points. We do not want to see that here. Okay, let's go ahead and console.log our sorted dice here. We get 3, 1, 1, 1, 1. Go ahead and get rid of that default case here. Is this breaking out of our while loop here? I don't know. I don't imagine why it would. Now let's go ahead and console.log and that sorted dice at index 0 here. We're going to see what's going wrong here. 1. We have 100. And then up here. Oh, there we go. There's where we were going wrong here. This needs to be plus equals, not plus. Alright, let's try that again, and we get the score of 1100 points here, and that is what we want to see. Finally, let's go ahead and do a dice roll 2, 4, 4, 5, and 4. And we should get 400 points for that trio of 400s. And 50 points for that 1-5 here, for a score of 450, which is what we want to see. Alright, I think I feel comfortable with punching this into Codewars to see what this looks like here. Let's go ahead and hit test. Let's go ahead and hit attempt. And we are good. Not really much to say about this one, but here is a fun fact about this dice game. The highest possible score you can achieve in this game is 1200 points, and you can achieve that by rolling 5 straight 1s. The first 1000 points comes from the trio of 1s at the start, and the other 200 points comes from the other 2 1s. Remember that you score 100 points for each individual 1, not part of a trio of 1s. And that is going to do it for today's episode of Versus Codewars. If you liked this video or you learned something new, drop a like and subscribe to this channel to see me take on more coding challenges on Codewars and other future content. As always, if you think there is anything I can do to improve on my code for the better, feel free to drop a suggestion in the comments section below. Also, if you are a Kata author on Codewars and you would like to share your authored katas with me, feel free to drop links to those katas in the comments section below as well, and you might see me take on those katas in a future episode of Versus Codewars. I hope you have a wonderful and safe day, and I will see you on the next episode of Versus Codewars.